Okay, and hello. I have made a review of this situation here with regard to this beam back here, and I had to look at it all really, and I was just going to try to annotate these plans, but I ended up just drawing them because I had to look at all the members to make sure that everything was okay as far as that goes if I was going to be involved. But first, before that, just so you know, all that lateral stuff was eliminated in 2019, in July 2019, when this code took effect. So none of that is needed at all, because we're not going to, it's a freestanding deck. No matter what we do, we're going to make it a freestanding deck. And I'll try to go through this fairly quick, so I make it simple. Just finished putting this whole thing together, including labeling the columns and the footings. You'll notice, I didn't notice these two here yet till later on. And labeling all these structural members so that I could try them out in my structural program. But first of all, I looked at them with regard to the code, because that's what Montgomery County is going to look at, presumably, or did look at. And this is the deck's beam span length, and those footnotes are this, which are just typical. And we have, for that deck's beam, using southern pine, and they don't specify the species or the grade, but just using southern pine, they are indicating here by this chart that you can only span those 7 feet, and that's clear span. And even if you went to 3 2x12s, you're still limiting that to 8 foot 10 inches clear span. I'm surprised with regard to this that they approved that much. But I wanted to see if this method would work according to my beam sizing program. And so first I analyzed beam 0A, but in order to do that, I had to first analyze the joists themselves, J0A and J0B. So I came over to review those members, the ones I had in so far, and this is the main joist, and that passes the 2x12s at 12 inches on center. And this is just the short ones, the little shorter joist on the other side of the stairs. This is the beam out at the outside edge of the deck, and its loads, and it passes regardless that the code indicates that it won't pass even with 3 2x12s, let alone 2. Said that was not allowed. But this passes it, and the city passed it, or the county passed it. So I'll just leave that alone. And 2 2x12s does it. And both of these beams were analyzed with this joist already analyzed as well, and that passed fine. These joists pass fine. This here fails according to the residential code, but has already been approved, A, and does pass, and I mean it's narrow, 98% on that for A. But I analyzed them both, A and B, and I put all this together just to make sure. And these are loads here in this orange text, are loads from that deck, just the floor loads from that deck. And then I later on recognized, okay, so we've got these ones here, they don't have any floor load, but they're going to be carrying that roof load. And in addition to these orange ones, roof load gets added to these orange numbers here, these pounds of bearing. Those two we don't know yet. So I went to 1C, and this is the ridge beam actually. And they were specifying in these plans and in the drawings and the sketches or the section views that this would be a single 2x8 at the ridge. And normally that would work. Okay, but I mean that's going to fail horribly. Look at this, 1120%. I knew that was going to fail, but normally when they're trying to do this and just use a single member up here, you know, especially if it's not 18 inches high or 16 inches high, LVL, they have to have cross members across here to hold this together. So that becomes a ridge board instead of a ridge beam. And you would have to use 20-foot ones that have to be unseamed, and I would think those are going to be at least 2x8s. I didn't test that to see what those would be. They're just for lateral restraint, so possibly even 2x6s. Another thing I didn't mention, because it's not shown in here, but I would have a row of blocking as high as these members are. I would have at least a row of blocking here and through here. Returning to this though, to that ridge beam, if you didn't want to put those things across there that I just talked about, if you wanted to somehow use a regular ridge beam instead of a ridge board, then, you know, select all of these things, including LVLs and all the available depths, and keeping it at 2 plies. These are the results, and the 2-ply members start at, these are just suggested here, but the 2-ply members, it's going to take two 11¼ to do that as a ridge beam instead of a ridge board. That's a short story there. This must be, yeah, that's that ridge board. Ridge beam. Once you use LVLs there, and they sell treated LVLs, they're expensive, but they do sell them. Now, in the event you didn't want to use a ridge board, a ridge beam, the 2 LVLs, the 2 11¼ LVLs, and you want to use a ceiling joist, I did double check that you would need 10 of them, it looks like, 20 feet long, and I did check those, and those 2x6s will do it with nothing on them, no load on them, at $33 a piece. So that would run you $330 for those joists, and then you could just use the 2x8 as shown in the drawings. I mean, you could do it anyway because they've approved them, but it will probably fall down early. And if you go to the ridge beam instead, you would need 2 20-foot LVLs because 18 just won't quite do it. You'd need 2 20-foot LVLs at $125 a piece. So the LVL solution is actually less expensive up at that level, except these aren't treated. So I don't know how you cover that. I'm sure the treated ones are twice the price, or something close to that. Anyway, that's an interjection. And this is going to be the load then, the additional roof load on those 2 ends of that ridge board or beam. So put in those numbers in the magenta, and that's all the roof loads, and transfer them down here and do the addition. And all of these are fine, all these external ones. It's this one and that one that are a problem. At, you know, this one here, the high one is 8780. When you go here to this little chart or spreadsheet, 8780 requires either a 30-inch, 29-inch by 29-inch square, or it requires, if it's going to be a drilled or circular thing, it's going to require, you know, somewhere in the neighborhood of 32 or 33-inch diameter. It doesn't have to be 2 feet thick though, it can be 10 inches thick. Would be more than enough for that. So those 2 there then, those have to be increased. All these other ones can stay as they are, 2 foot. But these 2 need to be increased. And you can see out here, this isn't a problem. And up here, my proposal, because of what you sent over with that picture of the hole and the existing foundation, at this here, where you have that hole out here some, but that foundation or that footing is right there. It's right there. If that's consistent across here, if that's all just at grade, and maybe they have a bunch of steel in here, I don't know. But either way, if you like to, it doesn't seem like it'd be too big of a headache, depending on what kind of soil you're dealing with. You can just undermine at each of those to get And these ones here, you would still need to undermine at least, to get under there. Ideally, you just go the whole thing, but this diameter only has to be 16 inches. So you only have to go under here a little bit, and it only has to be 8 inches thick or so on these light loads. This one's 3,000, which 24 is more than enough, and you would really only have to go in here the first 8 or so inches to undermine that. This one here is the more critical one, and that has to be a whole 32-inch diameter from the center of the, or 16-inch radius from the center of that column. But it doesn't matter. If you want to undermine that, you can, and that's the easiest way to do it, and just build it according to what's already been approved. And as I said, everything passed, except if you use a 2x8 for this ridge board, and that becomes a ridge beam because you don't have the cross pieces across here, that's going to fail, maybe even before it's got any snow on it at all. Maybe just the weight of the roofing, etc., because it had failed so much, 1100%. Now, in the event you didn't want to use a ridge beam, the two LVLs, the two 11¼ LVLs, and you wanted to use a ceiling joist, I did double check that you would need 10 of them, it looks like, 20 feet long, and I did check those, and those 2x6s will do it with nothing on them, no load on them, at $33 a piece. So that would run you $330 for those joists, and then you could just use the 2x8 as shown in the drawings. I mean, you could do it anyway because they've approved them, but it will probably fall down early. And then if you go to the ridge beam instead, you would need two 20-foot LVLs because 18 just won't quite do it. You'd need two 20-foot LVLs at $125 a piece. So the LVL solution is actually less expensive up at that level, except these aren't treated. So I don't know how you cover that. I'm sure the treated ones are twice the price, or something close to that. Anyway, that's an interjection. Vertically, I put this model together based on this drawing here. And I'm not sure, 42, maybe you wanted 42-inch railings, but those are only required to be 36. But I used these 3 dimensions here to build this model here. And this is what it looks like. They showed these things at 4 feet deep, but they really only need to be 2'8" below grade to the bottom of them. They're already 4 feet, presumably. They technically only have to be 8 or 10 inches thick. I mean, the big ones I would have 10 inches thick, but all those other ones really only have to be 8 inches thick. But maybe you're just going to pour the concrete now that the inspector's been there. So this was the undermining solution. If that footing is right at grade, like what it looked like in that photograph, and that's consistent in front of all of these columns, these 3 columns back here, I would just chow under that. And I don't know if you just try to, you don't have to go down to 4 feet is the thing. You really only need to go down 8 inches or 32 inches. And I messed this next operation up. It should have been moved up 16 inches. Those things are 16 inches deeper than they need to be. But I discover and correct that error a little bit later here. And if this is set up like this, and this is already drilled down to 40 or 4 foot out here, you need to be at 32, and you need to have that 32-inch diameter on that center one. Lesser on the edges, and that center one has to be pretty big, 32 inches. And I don't know whether you, I don't, maybe the best thing is to that 32 and then come up with, as long as you get 8 inches of 32-inch diameter, then you could just stick a sono tube in here that's, any 16 or 20, 24-inch diameter, and have it come up to the bottom of the footing, and then just pour that all at once. That would be one thing, because I don't know about undermining this whole thing and then leaving that out there floating, particularly with the soil, the water table, etc. But those are definitely things to think of. So if it was my house, that's what I would be trying to do, particularly on that big middle one. Those end ones, just to review all of these, at these edges though, I updated this number. This was an error. I had that at 1030. And these are these, that was what he was showing, 24 inch, and this is that 32 inch that we had calculated from that 8660. Those edge ones really only need to be that size. This is like a 20 inch diameter, and that's a 16 inch diameter. And if they're squares, this is 29 by 29, 17 by 17, and 14 by 14. And these ones at the edges, this one, it only goes about halfway under that footing, and this one goes a little further than halfway. And these blue circles presumably are the ones you've already drilled, the holes you've already drilled. And I go through something, but it's not going to be possible. And looking at each of these then, starting from this end, I'm showing the bottom of this here at 3'2", but it really only needs to be 2'8". But it's still pretty far from that footing, and I think you'd be okay doing it that way. In the middle, for the middle one, that's that 32 inch diameter one, and it only has to be 32 from the top, from the grade, and it only has to be about 10 inches thick. So it really has to be like that. But it's so close here, my guess is you just pour it all the way up to the bottom of that existing footing, if this is the situation, if I'm reading this correctly. And the last one down here at the left end, that again only has to be 2'8", 8 inches thick and 20 inches in diameter, and maybe that is also just brought up. And so that's that, another interjection. And so, because the alternative to that, to digging under that, is, besides presumably you have to submit revised plans, because the alternative is to pull all those footings out, or to leave them where they are, more or less. This one here you would have to expand some at least, but to pull those out and then drop that main beam, that beam B, drop that down to the extent that door through that wall will allow you to do. So hopefully that's 5 inches or so. And now that I've developed the model, I really don't think it's going to be able to be dropped much at all, maybe a couple inches. Then all these joists would have to be notched, and you would still use the highest joist hanger you could, which presumably is going to be like a 2x6 joist hanger, which will still be fine. It'll still have more than enough capacity to hold each of these joists. So that's the alternative, but presumably it's going to require revisions. I mean, the ridge beam, I don't know whether they're going to want a revision on that or not. Maybe you could just get by with building and tell them you decide to make it stronger. But I did not see, I don't think you can do that with any, I don't think you can do that ridge beam with any kind of thing that's not an LVL, even if you went to 3 plies, and they do have these, I've seen these at Menards, but they're generally not going to be Southern Pine #1. But say that you tried to use just treated lumber, regular treated lumber, and 2x14s fail. So the only way to do that is with the LVLs, that ridge beam. Yeah, well, I guess this is where we review that ridge beam just a little bit. It was a 2x8, and the way it's drawn without the cross pieces here, the ceiling joist, it has to be called a beam, and with those rafters hanging on it, or on top of it, or whatever you're going to do. But it takes this to do that. And I did look, just in case, in case it might help you, I looked at these soil types real quick, and you would still have to go, it's the same type of soil that's going to require that big footing, regardless. Right, this is actually one final interjection because I missed this going through those slides, and it was, instead of, because you can't really pull this back to have that ceiling load come on top, once you pull this bottom one back, you have the ceiling load if it's coming down against that wall over here, and that just can't happen. And when I say ceiling load, I mean the load from that beam 1C, from that ridge beam, of course. And so having the ceiling load come down on top of the beam is the only thing that can happen. That puts this column out here, and the only alternative to that then would be to move the support, the support near the house, into that framed wall and carry that down to the basement wall, the foundation. You'd have to block that in there on the first floor and the basement. But that would be an alternative. That would just completely eliminate that middle column there. But that's it on that. I know this film's been a mess because I've been going back and forth with various things, but hopefully it was understandable enough. So I think that's it. Call me if you want to discuss any of this. Thanks very much, and I'll talk to you soon.